Hi friends, welcome to my channel NM Learn Make Courses with Nagamani. And today we will see how to find the characteristic equation and eigenvalues and eigenvectors. So don't skip the class and watch till the end. Now coming to the problem, they are given a matrix and they are asking to find the eigenvalues and eigenvectors. If you see the solution, and we know how to write the characteristic equation where modulus of a minus lambda I which is equal to 0. Okay. Here A matrix is these 3 by 3 matrix they are given, and lambda is a scalar quantity where I is identity matrix, that is 1 0 0 0 1 0 0 0 1. Now I am writing here. Okay. 3 1 4 0 2 6 0 0 5. This is the A matrix minus lambda into I. I am writing directly where 1 0 0 now. So I am multiplying with lambda. Lambda 0 0 0 lambda 0 0 0 lambda which is equal to 0, and subtracting A from lambda I matrix, then we get 3 minus lambda. Here 3 minus lambda and 1 minus 0 1, 4 minus 0 4, here 0 minus 0 0, and 2 minus lambda here, and 0 6 minus 0 6, 0 minus 0 0, and 0 minus 0 0, here 5 minus lambda. Okay. Now we are finding the determinant of this matrix. Now we are finding the determinant of this matrix. Okay. Here 3 minus lambda into 2 minus lambda into 5 minus lambda. Okay. Minus 0 into 6 0, minus here 1 into, if you close this row and this column, then 0 into something 0, minus 0 into 6 0, plus 4 into, here if you close this column and this row, we are getting 0 into 0 0, minus 0 into something 0 which is equal to 0. Directly here we get 0, and this is also 0. If you see here 3 minus lambda into 2 minus lambda into 5 minus lambda which is equal to 0. By expanding this equation we get characteristic equation. Now I am not expanding, so by expanding this we get characteristic equation. From this we are finding eigenvalues, that are lambda values. Here lambda equal to 3 and lambda equal to 2, here lambda equal to 5. Okay. These are the eigenvalues of given matrix. Okay, these are the eigenvalues for given matrix. And now coming to the eigenvectors, how to, by using these eigenvalues we are finding eigenvectors. Okay, here if you see eigenvectors for lambda equal to 2 is, okay, here we are finding eigenvector for, we are using only one equation, a minus lambda I into x bar which is equal to 0. Here we know a minus lambda I matrix and directly substitute lambda equal to 2 in this matrix. Okay. By, sorry, I am writing here directly. Okay. 3 minus 2 we get 1, there is no change in 1, and 4 0, 2 minus 2 0, 6 0 0, 5 minus 2 we get 3. Okay, this is the A minus 2I matrix, and here x bar is the x y z vector which is equal to 0, and this matrix we are writing in equation form. If you multiply with this row into this column, we get 1 into x, x plus 1 into y, y plus 4 into z, 4z which is equal to 0, and 0 into x, 0 plus 0 into y, 0 plus 6 into z, 6z which is equal to 0. Similarly here also 0 into x, 0, 0 into y, 0 plus 3 into z, 3z which is equal to 0. From these two equations we can conclude z is equal to 2. Okay, z is equal to 2. Here 4z which is equal to 0. In order to find x and y, we have to know any one value. So we are assuming let y equal to k1 parameter. Okay, we are assuming y equal to k1 parameter. By substituting y equal to k1 in this equation, we can find x equal to minus k1. So now we know x, y, z values. Now we are writing matrix vector form is x bar is equal to, here x is minus k1, y is k1 and z is 0. Okay, and if k1 by common, k1 as common, then we get minus 1, 1, 0. And I wrote the A minus lambda I matrix here. Okay, now we are finding eigenvector for lambda equal to 3. Okay, if you see the if you see the vector form matrix is A minus lambda is 3 into I into x bar which is equal to 0. So substitute lambda equal to 3 in this matrix. Okay, we will get 3 minus 3, 0, here 1, 4, 0, 2 minus 3 we get minus 1, here 6, 0, 0, 5 minus 3 we get 2, and where x bar is the vector form of x, y, z which is equal to 0, and this matrix we are writing in equation form and multiply with this row into this column, we get equation form 0 into x, 0, and 1 into y, y plus 4 into z, 4z which is equal to 0, and similarly minus 1 into y, minus y plus 6 into z, 6z equal to 0. Here 2 into z, 2z which is equal to 0. Okay, from this equation we conclude z is equal to 0. If you substitute z equal to 2 in this equation, we get y equal to anyone. This equation we get y equal to 0. So we are assuming x value as k2 parameter. Okay, we are assuming x is equal to k2 parameter. Now coming to the vector eigenvector for the lambda equal to 3 is x bar is equal to here x, y, z, where x is equal to k2 and y equal to 0, z equal to 0, and by common k2 into outside the matrix, then we get 1, 0, 0. This is the eigenvector for the lambda equal to 3. Okay, and now we have to find one more eigenvector. Okay, eigenvector for lambda equal to 5 is, okay, eigenvector for lambda equal to 5 is, and now I am getting here 3 minus 5. Okay, sorry, here I am writing A minus lambda I matrix 3 minus lambda 1, 4, 0, 2 minus lambda 6, 0, 0, 5 minus lambda. Okay, here in place of lambda we are substituting 5. 3 minus 5 we get minus 2, and 1, 4, 0, 2 minus 5 get minus 3, 6, 0, 0, 5 minus 5, 0, and where x bar is the x, y, z vector which is equal to 0. And now we are writing this in equation form is minus 2 into x minus 2x plus y plus 4z equal to 0, and similarly for next row minus 3y plus 6z equal to 0. Okay, value. Here we are assuming let z equal to k3 parameter. Okay, by substituting k equal to z equal to k3 in this equation, we get 3y equal to 6k3 and y equal to 2k3. Okay, we get z and y values. So by substituting y and z in here, we get x value 2x equal to y is 2k3 plus 4 into z 4k3. Okay, which is equal to x equal to here 6k3 by 2 we get 3k3. Okay, this is we are getting x y z values. Now the eigenvector for lambda equal to 5 is x bar is equal to here x is 3k3 and y equal to 2k3 and z is equal to k3. Okay, and here we are commoning k3 is common and here 3 2 1. This is the eigenvector for eigenvalue of 5. Okay, in this way we are finding eigenvectors and eigenvalues for the given matrix. If you have any doubt, please comment below and we will solve more problems which are given in competitive exams in next video. And thanks for watching.